Hello and welcome. Today we're gonna take a look into logic and truth table. Let's take a look at the definition of an argument. So an argument is a sequence of statements aimed at demonstrating the truth of an assertion. The assertion at the end of the sequence is called the conclusion, and the preceding statements are called premises. So to have confidence in the conclusion that you draw from an argument, you must be sure that all the premises are acceptable on their own merits or follow from other statements that are known to be true. So we're gonna consider the first argument. Here we have if the bell rings. So this is gonna be our first premise. We're gonna call it P. And then, or the flag drops. I'm gonna underline it. This is our second premise. I'm gonna name it Q. Okay? Then the race is over. So then the race is over is our conclusion. So we gonna name it R. Alright, so this one, if we do the negation of this, I'm gonna write this at the negation of this argument. So if the race is not over, then the bell had not rung. Oops. And the flag had not dropped. Okay, so first we look at the negation of the conclusion. Is gonna be in the if statement. So this one we have the race is not over, right? So this one is R, but then have the not over here. We said it's not R. Okay, then the bell had not rung. So this is our B with a not. We're gonna call it not P. And then the flag had not dropped. Second premise, and have a not in here. So I'm gonna call it not Q. So from this first argument up here, we can also jump to the conclusion. Therefore, if the race is not over, then the bell had not rung and the flag had not dropped. Okay? So now we're gonna look at some form of writing not R, not P, and not Q. Okay? So for me personally, I like this way. So not R with like how you say it, overline. So the line on top of the R, or you can do something like this. This is not R, and also this. Okay, if you see some like college algebra videos, you'll see people use this symbol a lot, but I like this way better because it's simple. So yeah. Okay, so now in short, we can jump to the common form of the argument is, I'm gonna do green. Okay, common form of the argument. Okay, if, okay, I'm going to put or, then, okay, so if P or Q, then R, and therefore, I'm going to put this, not then, not this, or not that. Okay, if not R, which is the conclusion is not happen, then all the premises could not happen. Okay, so then not P or not Q. All right, this is our common form of the argument. Okay, so now we're gonna look at the logical form. So our common logical form is if something, then something, and then something in here, therefore something. Okay, I'm gonna use P and Q. So if P, then Q, and then P, therefore Q. Okay, let's look at one example. Okay, so let's say if it is raining, then the ground is wet. Okay, so we're gonna name P is it is raining, and Q is the ground is wet. Okay, so let's use the common logical form to write down an argument. Okay, so we have if it is raining, right? If P, then Q, so then the ground is wet. Okay, or we can do it is raining. Therefore, the ground is wet. All right, this is our common logical form. Now let's look at some definition of a statement, or also called proposition. Okay, so what is a statement? A statement is a sentence that is true or false, but not both. So you can say something as a statement if you can determine if it's true or false. Like for some example, if we have P1, let's say P1, okay, equals 2 times 2 is 4. Is it a statement? Oh, let me ask you first. Is it true? It is true, right? Okay, so since we can easily tell this sentence is true, we can call it a statement. Okay? How about let's call P2 equals to 2 times 2 equals 5. Is it true or false? It is false, right? False. And we know it is false, so it is also a statement. Okay? Can you think of something that we can neither tell is true nor false? Okay, let's say P3 is pizza is bad. Is it true or is it false? We don't know, right? Some people think it's good, some people think it's bad. It's an opinion, right? It's not a statement. You don't know if it's true or false. You can get an answer right after this. So it is not a statement. Oops. Okay, so let's do one more. Let's say x is greater than 3. Is it true or is it false? Or neither? Neither, right? We don't know if it's true, if it's false. If we just know that x is greater than 3, we don't have anything else. How can we know if it's true or false, right? So this is also not a statement. Okay, so now we all know about the definition of a statement. So a statement is a sentence that you can tell right away if it's true or false. Not a statement is you cannot tell if it's neither true nor false, right? So for example, a sentence, an opinion, or a phrase. All right, let's move on. Let's move to compound statement. So we're looking at a table that has the symbolic operation here. So we have not. As I said, we can write this at this form. We have 3 of them. It's mean not P, right? So for example, I have this and then the line on top. It's called not R, right? And this is the negation of P. So yeah, that's the not. So what we have and the symbol of and is like an upside down V, and you can imagine it like this. So you have a line, a horizontal line across it, and then you put and. So that's how you remember and recognize if which one is and or which one is or operation. Okay, so we can write it symbolically like this, P and Q. And we can tell, yeah, this is just the speaking version of it. And this is called a conjunction of P and Q. All right. And we have or as last. So we have the V symbol and is right symbolically like this. P and then V, Q. Or we can say P or Q, and this is the disjunction of P and Q. All right, so the order of operation is first we have the negation. I'm gonna write order of operation. So we have the negation first, which is the not. I'm gonna write this. And then followed by is the and, which is the conjunction, right? So the upside down V. And then last one is the or, which is the V. Okay? So if somebody said or, if I said Q but P but Q, so B but Q, it means P and Q. Okay? Or I said neither P nor Q, it means not P and not Q. All right, let's do some example. I'm gonna let it, okay, example. Okay, I'm gonna let P is, it is hot. And Q is, it is sunny. Okay, so I have a complete sentence. So first I have, it is not hot, but it's sunny. Okay, and the second one I have, it is neither hot nor sunny. Okay, go ahead and write each following sentences symbolically. All right, so we have it is not hot. So we know that our P is it is hot, right? We have a not over here, which is the negation of P. So we have P and then the negation of P, right? But it is sunny. So we have but here. We know that P but Q is P and Q, right? So we have and it is sunny. So this is just our Q, right? So I'm gonna put not P and Q. Oops. Okay. How about second one? It is neither hot nor sunny. So we know that neither P nor Q is just not P and not Q, right? So we know that it is not hot is not P. And then and not Q, so it is not sunny. Not Q. All right, that's it. Okay, let's do one more example and we move on. I'm gonna give you 3 sentences and you're gonna write each following symbolically. Okay? So first one we have, oops, it's an eraser. So first one we have John is wealthy, healthy, and wise. Our second one is John is not wealthy, but he is healthy and wise. Okay, our third one is John is neither wealthy, healthy, nor wise. Okay, so I want you to do, all I want you to do is convert these sentences symbolically. Okay, go ahead, pause, and do this problem. Okay, let's do it. So first we're gonna assign letters to represent the component statements, right? So I'm gonna say A, oops. A is John is wealthy. B is John is healthy. And C is John, oops, I messed up. John is wise. Okay, so let's do first sentence. John is wealthy, healthy, and wise. How can we do it symbolically? Okay, so we have A, John is wealthy, healthy, so and B, right? And then wise and C. Okay, this is our first sentence. I'm gonna write this up here. A, let's do different colors. A and B and C. Okay, how about our second? John is not wealthy, but he is healthy and wise. Okay, so we have the negation of A, right? John is not wealthy, so we have not A. But he is healthy and wise, so and B and C. Right? Okay, how about our third one? John is neither wealthy, healthy, nor wise. Okay, we all notice that these are all negation, right? So we're gonna do not A. Oop. Not A. And not B and not C. All right, we all good. Finally, we get to the truth values and the truth tables. So, let's say if P is a statement variable, the negation of P is not P, right? So I'm gonna say, if P is true, then the negation of P is not P, which is not true, and it is false. So it has the opposite truth value from P. So let's draw a truth table for that. Okay? So we have P and not P, right? And separate it, have true, false. Okay, so if P is true, then not P is what? Not P is false, right? Or if P is false, what is not P? Yep, not P is true. Okay, or you can write true, false as 1 or 0, right? It's like turn the light on or off. If you turn the light on, there is light, right? So it's 1. If you turn the light off, there is no light, so it's gonna be 0, right? It's like a switch visualization for like 1, 0, or true or false. But we can do like a different way like this. Okay, I'm gonna do the same as true, false, but instead I'm gonna write 1 and 0. Okay, 1 is true and 0 is false. I'm gonna write it up here. 1 is true and 0 is false. Okay, so let's move back again to our truth table over here. Okay, P is 1, then not P is what? Oh, what's happened? That is weird. Oh, I don't know what happened. Okay, so if P is 1, then not P is 0, right? How can it disappear? Oh my god. Panic. We got this, okay? So we have not P is 1. I mean, P is 1, then not P. What the freak? Okay, not P is 0, right? And we have P is 0, so not P, obviously 1. Okay, that is our truth table for the negation. How about the conjunction statement? So we have if P and Q are statement variables, the conjunction of P and Q is basically P and Q. It is true, this statement is true when and only when both variables are true. Okay, so let's draw a truth. I'm gonna write this as not negation statement. This one is and. Okay, so let's draw our truth table with two variables, P and Q, and we have P and Q. Okay, so for this one we have two variables, so we need to have 4 rows, right? We have true, true, false, false, and then true, false, true, false. Okay, so we know that in an and statement, it is true and only true when both are true, right? Okay, so we have both true here, so P and Q is true, right? We have one true and one false. It is false. One false and one true. It is false. And one false and the other is so false is also false. Then it is false. Okay? So we're gonna write it at 0 and 1s, okay? So P, Q, P and Q. All right, we have 1 0 1 0 1 I'm made a mistake. Okay, we have 1 1 0 0, 1 0 1 0. Okay, so we have P and Q. First row we have both ones, right? We have 1 for the statement. So 1 and 1 is 0. 0. 1 0, 1 is 1. 0. 2 zeros? 0. Okay, so let's talk about like what should we determine if how many rows are in a truth table. Okay, so for example, in here we have 2 variables. We're gonna do it at 2 to the n power. Okay, so it's like binary code. We have if it's just 1, right? If n is 1, which is just 1 variable, then 2 to the power of 1 is just 2, right? So we're gonna have 2 rows like this. Okay, for two variables, we have n equals 2 and 2 to the power of 2. 2 squared is 4, right? So we have 4 rows. And 4 columns. Oh my goodness, 4 columns. Sorry, y'all. Okay, how about 3 variables? So like P, Q, and R. How many columns should we have? 2 to the power of 3. 2 cubed is 8. Okay, so we're gonna have 8 columns of variables. So this one we can do true, 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 false, 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 and then true, true, false, false, true, true, false, false, and we have true, false, true, false, true, false, true, false. Okay, if we have 4 variables, for example, let's say we have W, right? It's gonna have 16 columns. It's gonna be too much. So usually the maximum problem that you might see is like just 3 variables. So just make like 8 columns of this. Okay. All right. Let's do OR. Okay, so if P and Q are statement variables, the disjunction of P and Q is P or Q. Okay, so it is false when and only when both are false. Let's draw a truth table for this. So we have P, Q, P or Q, right? Okay, we have 4 columns. True, true, false, false. Okay, for Q we have true, false, true, false. All right, so P or Q is only false when both are false. Okay, so we have true, true, then it's gonna be true. True, false, still true. False, true, true. False, false, false. Let's do is at 0. P, Q, P or Q. Okay, so 1 1 0 0, 1 0 1 0. Okay, 1 or 1 is 1. 1 or 0, still 1. 0 or 1, still 1. Oops. 0 or 0, 0. Okay? All right. So yeah, that's what we have for the truth table. And for the next video, we're gonna look at some problem that we can use a truth table to solve. All right, I'll see you guys in the next video. Bye.